Okay. Gia, can you see that screen?
Yes, I can, sir.
Okay, perfect. Okay, let's just give them a couple of minutes to join. All right. Got a few people here. All right, guys, so we're going to do the 2020 paper. Okay. Who we got here? Is that Leia? All right. Okay. See something? Okay, so we have Gia, Leia, Umuka. All right. Okay, guys. So I want you to try to start the first question of the 2020 paper. Okay. So here, I'll go to my screen here. All right, Rosemary, Bukanya. All right, so people are coming in. All right. Let us minimize that. Okay. All right. Rosemary, you can see that screen and hear me, yeah? Your mic doesn't. Okay. All right. So let's go, guys. Okay, so we're going to work for half an hour solid. Then your brains will be a bit fried. 5-minute break. Okay, another half an hour. So actually, Rosemary, time 25 minutes for me. No, I'll do it on my own time. Yeah. All right, guys. So start with question 1. I'm going to join you now. So we're going to be doing 1.1 first of all. Okay. You know the paper here has a question. Okay, a collection of antique toys contains 6 train sets. Okay, 5 model cars and 3 vintage toys are displayed in an auction. 3 of these items are sold. Find the probabilities that all 3 items are of the same type. Okay, start that. Don't look at the memo, guys. I really need you to start to think a little bit. Okay, yourself. So give it a go. Give you 2 minutes. All right, guys, let's have a look at the first question. Okay. So it says here this pen's giving me a hassle now. That's all right, man. Okay. Right. So you've got a collection of antique toys containing 6 train sets, 5 model cars, and 3 vintage toys. So first of all, how many things do we have in all? The total number of toys. So for 1.1, okay, the total number of toys is 6 plus 5 is 11 plus 3 is 4. So they're 14 toys. Okay. Said 3 of these items are sold. Find the probability, they should say randomly sold, are randomly sold. Find the probability that all 3 items sold are of the same type. So 2 things. So the probability of an event is the number of ways the event can take place over the number of elements in the sample space. Okay? And the event would be, you could either sell, you could choose all 3 trains, or all 3 trains, or 3, what are the other things we've got? Model cars, or 3 vintage toys, right? So that's the ways you could get 3 of the same, okay, over the sample space. You don't have to write this line over here down. Okay, so the number of ways you could choose, so you've got to choose 3 trains. Remember, order doesn't matter, okay? There's no order to the trains, okay? You just got to get 3, okay? So you've got to get 3 trains, okay, and the total number of trains is 6, right? So you've got to get 3 trains from 6. Okay, I actually prefer writing my sample space down first. I'll show you why now. Okay, so overall, what am I doing? Okay, you're choosing 3 things from a total of 14 toys. Okay, so basically the question is saying 3 toys are randomly chosen, right? Would be a better question in my opinion, from 14. So that's the sample space. That's what's happening overall. What are you doing overall? You're choosing 3 from 14. Okay, so I want to get 3 of the trains from 6. If you can put in this negative space. Okay, by the negative space, I'm kind of think you can use it as a check, but you don't have to write what I'm writing in red. Okay, you're choosing none of the other 8. Okay, if you want to put that in, you can. Sometimes it helps people that feel confident because then you've got 14-3, and then those always balance. Okay. Or, okay, you're choosing from the model cars. How many model cars are there? There's 5 model cars. So from the 5 model cars, you randomly choosing 3. Okay. How many of you choosing of the other? The negative space is you choosing none from the 6 trains and the 3 vintage toys, which is 9. But as I say, you don't have to write the red because 8 choose 0 is equal to 1 and 9 choose 0 is also equal to 1. So I've done the 3 trains, I've done the 3 cars, or, so plus, okay, and then the last thing are the vintage toys, of which there are 3. So I've got to choose 3 from 3, okay, and then the negative space would be, well, of the remaining 11 toys, I'm not choosing any. On your calculator, anything choose 0, guys. Don't waste time. Anything choose 0 is just 1, and anything where that's the same. So n choose 0 is always equal to 1, okay? And a choose a is also equal to 1. Gia, if you want to write the test that the aunties are writing tomorrow, it's basically like a prelim. You're welcome to find some time and just sit in my class and write it if you want to, and I'll mark it. Okay. All right. So stick that all into your calculator. Okay. Just go check your answer because they'll never mark you wrong, guys, if you leave an answer as a fraction. Okay. I don't even know who we got online. Rosemary, have you got an answer for me?
You want the fraction or the decimal, sir?
I thought you. Sorry, I heard what the fraction. No, I want the fraction. Yes, either one's fine. So
it's 31 over 364.
Yeah, and if you do as a decimal, it'll be 0.0. What the fraction? 0.0582.
Yeah.
Okay, guys, I can't see hands, so please shout if you have a question. Okay, but remember, a combination is when you're choosing. Okay. All right. Try 1.2. Okay. 1.2. Okay, just try start it. 1.2a. I start my timer. Didn't. Okay. Do 25 minutes from now. Right. You should have a formula sheet with you guys. Okay, so the first part, guys, is trying to identify what you're working with here. Okay. So it says the results of a random survey show that 70% of students listen to music while studying for an assessment. A random sample of 5 students is selected. Find the probability that more than 3 students listen to music while studying for an assessment. Okay, so my question is, how can I check if this is a binomial situation? Okay, the key for me is by choosing one student, does the probability of the next one listening to music change? And it doesn't. If I pick, let's say, sorry, Rosemary, I saw you online, so I'm picking on you. If I choose Rosemary and Rosemary listens to music, it doesn't affect the chances that Umika listens to music. By withdrawing Rosemary doesn't change the probability. So that probability stays fixed. Okay. The probability of listening to music is fixed at 70%. That doesn't change. Okay. And in addition, there's only 2 choices. Student listens to music or doesn't listen to music. Okay. So we're going to be using binomials. So go write down the binomial, find the binomial theorem on your formula sheet and write it down. Now I'm saying you should have a formula sheet and I don't have a formula sheet. Okay, p to the x, but it is that. What, 1 minus p, what have I done wrong? To the n minus x. All right. So, Gia, sorry, I'm going to pick on you because I remember you there as well. What is p in this formula? So what is x? You won't get penalized, but I like to define x. Okay, so x is going to be students listening to music. Don't have to write that down, but that's what it is. Okay. And then it says, a random sample of find the probability that more than 3 students listen to music. So Gia, what is in this formula, if X is the number of students listening to music, P is the probability that they listen to music. So what's P equal to?
0.7.
Okay. And what are we trying to find in terms of this notation? We're looking for the probability that more than 3 students, right? So we're looking for the probability that X is greater than 3. Okay. And what's N, Gia?
N will equal 5.
Good. Okay. So we're looking for the probability that X is greater than 3. Now, a lot of you always want to go 1 minus. Sometimes that's a lot quicker. But but X is bigger than 3, okay, is simply 4 plus 5, right? Okay. So the direct way is quicker than the indirect way. So if I said to you, what was the probability that more than one student, okay, or that one or more students, so if I'd asked you this, probability that X is greater than equal to 1, well, then it would be tedious to do the direct route. In other words, to do X is equal to 1, X is 2, plus X is 3, plus X is 4, plus X is 5. So in that case, if the question had been, what's the probability that more than one students, I would have said 1 minus, so that probability X is bigger than 1 is 1 minus the probability that X is less than 1. In other words, 1 minus the probability that X is equal to 0. So sometimes using the complementary space is quicker, but not always. In this case, the probability that X is bigger than 3, okay, the quickest way to would be to go the probability that X is equal to 4 plus the probability that X is equal to 5. Okay, so you're going to put 4 and 5 into the binomial theorem, right? Go from there. I'm going to put them both into this formula over here. Go for it. Should be probability actually small x is 4 and small x is 5. Okay. No, it shouldn't be. Okay, right. So I'm going to get NCX. So it's going to be 5, choose 4. P is 0,7 to the x is 4. 1 minus p is 0,3. 5 minus 4 is 1. Okay. Plus 5, choose 5. This will be for probability x is equal to 5. So it'll be 5, choose 5. 0,7 to the 5. 0,1. 0,3 to the 0. Now, guys, something you really should be picking up, don't forget, is that remember you're racing against time. 5, choose 5 is just 1. You shouldn't enter that into your calculator. 0,3 to the 0 is just 1. Okay? So here, in this part of the sum, you only have to enter 0,7 to the 5. Okay? Right. Go stick that into your calculator. And Gia, what did you get as your answer, if you've done it?
I got 0,5282.
Okay, perfect. All right, so why was it binomial though, guys? Because by picking one student, okay, the probabilities don't change. If your probabilities don't change, the example I always use is the probability of you scoring a goal. If it's 60%, okay, then you score a goal one time, the next time it doesn't change. Okay, so if they give you the probability, like in this case, chances are you're using the binomial theorem. Okay, right, try question B. Well, the big hint is using a suitable approximation. So guys, if we look at this question, I'm going to give you time now. A second sample of 60 students is selected, right? The random variable x denotes the number of students, okay, who listen to music while studying for an assessment. Okay, using so x is equal to number of students music. Using a suitable approximation, well, anytime you see that, it's going to be the normal approximation to the binomial. Okay, find the probability that at least 40 students of the sample selected listen to music while studying for an assessment. Okay, part 2 says justify the use. Okay, so you don't have to show that NP is bigger than 5 in part 1, or N1 minus P is bigger than 5. That comes in question 2. Okay, so try question 1, normal approximation to the binomial. Okay, so we're looking for, right, go for it. Why couldn't we use the normal, just binomial? Because you'd have to work out x is equal to 40 plus x is equal to 41. You'd have to do like the binomial theorem 20 times. Okay, so that's not going to work. Okay, even if they didn't tell you to use an approximation, okay, the only way we could do the sum with is a normal approximation to the binomial. So the first thing I'm going to have to find, if you don't have to justify it, is you have to find mu for the normal approximation, and you have to find your standard deviation. So if you go to your formula sheet, right, so can somebody just send me a photo, Rosemary?
Yes.
Do you have a formula sheet there?
Yes.
Just send me a photo of the stats, not the table, just the actual formulas for stats.
Okay.
Thanks. Okay, so how do I find mu? Okay, Well, on your formula sheet, I just want to see how they express it. Okay. Thanks, Rosemary. Got it. Okay. If you look on your formula sheet, there's a formula which says, this can help you, E of X, which is this is for this formula is for binomial. So if they ever ask you what is the expected value of this binomial scenario, okay, or the expected mean, E of X is equal to NP. So on your formula sheet now, where you see that E of X is equal to NP, that's for the binomial distribution, right? You assuming discrete data. But that can help you because when you move that into, okay, a normal approximation for the binomial, okay, we're just going to use that same formula, but now it's mu because mu is for continuous data. So mu is equal to NP is going to be our estimate of mu for this distribution. And then also on your formula sheet, it says the variance of X, okay, is equal to NP 1 minus P, okay? Well, that's for again, this on your formula sheet is for a binomial distribution. So if they ask you for the variance of a binomial distribution, that's what you'd use. Okay, but when we move it, we use the same logic when we move the binomial into the normal. Okay, so in this case, instead of talking about variance, we'd say sigma squared, because variance is sigma squared is equal to NP 1 minus P, which means that sigma is equal to the square root of NP 1 minus P. Okay, so go work out mu and go work out sigma with this data. So n is equal to, with this distribution, n is equal to, how many students were there? N is equal to 60. And P, which is the probability of what we're looking for, which is the number of students, okay, who like music, is X. Probability is 70%, which is 0.7. So you'd expect, okay, mu to be equal to 60 times 0.7. So out of 60 students, you'd expect 42 to be, okay, to like listening to music. Sigma would be equal to the square root and you should get the square root of 12.6. But I didn't have my calculator here, that's useless. Okay. The square root of 12.6, how did your calculator give that to you? What was the format it gave for that? Somebody got that? Rosemary or Gia? You guys hear me? Anybody?
Yes, sir.
Okay, who is that? Is it Rosemary again?
Yes.
Okay, sorry, Rosemary. What do you get? I'll find who else is online just now. What did you get for when you put square root of 12.6 in your calculator? What does it give you? Does it give you something different?
3.5496.
Okay, don't round off here, guys. 3.54. If it's in a third form, rather leave it like that, or else don't round off. Okay, so we've got mu is 42, and we've got sigma is equal to 3.5496. Okay. Right, now we've got to go work out. Now we move into so this, okay, is for continuous data once we're moving into a normal distribution. Okay, so I've got mu is 42. I've got sigma is equal to 3.5496. Now we're looking for the probability. So let's go start our diagram. Okay, the question says that at least 40 students. This is the one time in normal distributions where the equal signs matter. So in binomial language, we're looking for the probability that X is bigger than or equal to 40. And in binomial, that's fine because 40 matters. It could be 40 plus 41 because you're working with discrete data. But when you move that into a normal, we're not working with discrete data, we're working with continuous data. What that means is you've got to do your error. Okay, so if we have our X scores over here, we have mu is equal to 42. Okay, so that's in the middle. And we're looking for the probability X is bigger than or equal to 40. So 40 is over here. Now, when you're doing a normal approximation to the binomial, okay, the probability of X is 40 is 0. So you can think of 40 as being a bar, okay, a region. And you want to include the whole of the 40 bar. So your error, your correction for moving it to normal, if I want to include the whole of the 40 bar, okay, this is only for normal approximation to the binomial. What we're looking for in normal distribution language is the probability that X is greater than or equal to 39,5. I'm including the whole, to include the whole of the 40 bar. Okay, I start from the left boundary over here, which is 39,5. If the question had been, what's the probability that X is less than 40 in the binomial language, then I wouldn't have wanted to included any of the 40 bar. Okay, so it would have been X is less than, in the normal language, it would have been X is less than 39,5. If they had said the probability that X is just bigger than 40, then it means I don't want any of the 40 bar. So in the normal language, the edges of the boundary are going to be 40,5 and 39,5. So in normal language, you would have looked for the probability of X is bigger than 40,5 because you don't want any of the 40 bar. Here it said bigger than or equal to 40. So you want the whole of the 40 bar. So you go from 39,5, right? Okay, so I get probability X is bigger than or equal to 39,5. Okay, so that's going to be your X score in the normal formula. Now it just becomes a normal distribution question. Okay. So we're going to say, we're going to get our Z score. It should be negative because it's to the left of the mean. And mu was 42, eh? Over 3,5496. And you should get a Z score, okay, of negative 0. Did you get Z is equal to negative 0,7? If you didn't, please shout out. Okay, so that's your Z score here. There's Z is equal to 0. So it's negative 0,7 standard deviations to the left. Okay. Right, and what region are we looking for? We're looking for the whole of this region over here. That X is bigger than or equal to 40. So what we've got, Z is equal to negative 0,7. Okay, so the probability, so if you look up 0,7 on your table, so the probability that X is bigger than or equal to 39,5 is going to be equal to, well, we've worked out now that this green area over here, so if you go to your table and you look up a Z score of, remember you can't look up negative Z scores. Okay, so that's H of 0,7, and you should get H of 0,7. H of 0,7 means the area that goes with the Z score of 0,7 should be 0,2580, according to this. So the area we want, the probability that X is bigger than or equal to 39,5 is going to be that green area, which is 0,2580, okay, plus the remainder of the yellow area, which is 0,5. And so you end up with an answer of 0,7580. Okay, so normal approximation to the binomial. Okay, remember you've got to work out mu. Okay, and to find mu is equal to NP. Use your formula sheet to help you. Mu is the same as the expected value. You've got to work out sigma, okay, which is the square root of NP. Use this formula to help you. Once you've got those two parameters, treat your number that you're looking for as a bar and say, do I need to include the whole of the bar or do I exclude the whole of the bar, depending on whether it's less than or less than. Any questions? Okay, people don't normally ask questions on this format for some reason, but we'll try. Nothing. Going, am I speaking to myself? Who knows? Going, gone. Roger, do you have any questions? No, I'm fine. Right, so go to part 2 and part 3. How the hell did we do COVID? Okay.
Sir, can you please move your screen to the...
Back to the questions.
Yes, please.
Okay, sorry. Who was it? Fatsai?
No, it's Butlali.
It's Lale. Good, I've got somebody else to pick on. Right. Okay. So justify the use of the approximation mathematically is question 2. Question 3, why does this justification need to be improved to ensure that the approximation in 1 is suitable? But Lale, can you remember what's the criterion? Don't worry if you can't do it. Do you remember the criterion, but Lale, I just got to talk to somebody, for using a binomial a normal for a binomial?
Not at all, sir.
Gia, can you remember?
Okay, I'm not sure, but is it when n times p is greater than 5?
Okay, so you've got to show that, and you've also got to show
That n times 1 minus p is greater than 5?
good. If both of those criteria are met, it means it is appropriate to use a normal approximation to the binomial. Okay, you can't always do that. Okay, so in this case, n was equal to the number of students, which was 60, and p was equal to 70%, which is 0.7. Okay, and if you punch that into your calculator, you get 42, which is bigger than 5, so that condition is met. Go check the other one. And that'll be 60 times 0.3, which is equal to 18, which is bigger than 5. So both conditions are met. Okay, so you can use the approximation, normal approximation to the binomial. Okay, so that one thing you got to remember, there's nothing on your formula sheet, comes up often. Okay, and the reason is, which is what they ask you in 3. Okay, why does just justification be needed? Because if it's got to do with skewness, okay, because it shows the data is not skewed. I'm not going to get into that now. Okay, because the data is not, i.e., that it simulates normal distribution. Because if one of these things isn't bigger than 5, it means you could either have a shape of your distribution, instead of just being like this, okay, like balanced, you could have a peak to the left, and then it tails off far to the right, or the other way around, tails off to the left and spikes to the right. Okay, so the memo actually says, let's just see, this allows for symmetry and not for the distribution to be either positively or negatively skewed. I'm getting a whole lot of messages. Is it one of you guys? No. So this is very amusing for us. Not very amusing for me. Right, okay. Right, go to question 2, you clowns. I actually want to see who's here, because I'm going to start picking on people. Okay, try start question 2. Let's just see if anyone's still here. Whoa, we've got Olivia, Zara, Zachra, Mthumin Zako, Gia Umikalea. What is quite fascinating about this is I had some people in my class beg me for a lesson today. And are they here? No. Interesting. Okay. Right. Emma, if you watch this video, I'm going to check tomorrow if you recognized your name was mentioned. Okay. Yes, we want a lesson. We want a lesson. Okay, right. Try the next question. We'll have a break after question 2.1 before my mental insanity kicks in. But this is quite good therapy. Erasing things. Okay, can you imagine? So nice. Okay. Zaku. The other people from the other class. Okay, I've told my classes before, they don't seem to believe me. I'm not particularly worried about, in fact, I'm not worried at all about your marks for tomorrow. If tomorrow is a disaster, okay, and I don't expect it to be brilliant, quite frankly, okay, but you never know. I'll hike the average up. Okay, so your marks I'll inflate your marks for your report. This is not really about your report. Okay, it's about trying to get you into the zone for 2 weeks' time. Okay, and if tomorrow goes badly, 2 weeks is a lot. Okay, to get to grips with this, but we need to start getting you focused. Okay, so please don't panic about the mark tomorrow. For me, it's irrelevant. Okay. Right, so the next question says, okay, a random variable x, okay, is normally distributed. The mean is twice the standard deviation. So let's just start off by writing 2.1. It's a normal distribution and mu is twice the standard deviation. Okay. Am I right? Mean is twice the standard deviation. It is given that the probability that x is bigger than 5,2 is equal to 0,9. Find the mean and the standard deviation correct to 2 decimal places. Again, guys, I don't look at this and think I know exactly what I'm going to do. Okay. In fact, I just about never look at stats and think I know exactly what I'm going to do. I just go with what I've got. Hopefully something works out. Right. So we draw a picture. So I've got a normal distribution. Okay. I've got my X scores, I've got my Z scores. Okay. Now, how do I know if this 5,2 is to the left or to the right? Well, the probability that x is, because that is bigger than 5,2, is 90%. It can't be here, okay, because if it's there, there's no way that's 90%. It's more than 50%. So it must be to the left, right? Okay, so 5,2, okay, must be situated down here somewhere. Okay, so an x score of 5,2 is there. Okay, mu lives here with a z-score of 0. So this z-score here must be negative. Okay, it's a common mistake. People forget to put the negative into the z-score. Okay, so this area over here is 90%. This whole area in green is 90%. Okay, that's 0,9. Okay, so to use our table, I need the area between mu and the zx score, which is this yellow area over here. Okay, so that's what the table will give me, that yellow area. So if I look up h of, no, okay, so I know that h of, let's call this z1. So h of z1 is equal to 0,4, right? That yellow area is 0,4. Okay, so go look up 0,4. Okay. So you're looking for the area. So you're starting with the middle numbers and you're finding your Z scores on the side. Nsumi and Sako, have you done this? Or would you like me to pass
Yes,
it?
sir.
Okay, so what did you get, Nsumi and Sako, for h of z, 1? So what's z1 equal to?
Z1. Oh, okay, wait, sir. So when you said
So you look up.
have I done it?
So you look up an area of 0,4 on your table.
Yes. My Z score was negative 1,28.
Brilliant. Okay. So your Z score is, so that lives here, negative 1,28, right? Okay. So you've got your Z score is equal to negative 1,28, right? And what did the question say now? Okay, now we've got to get a formula for the mean and the standard deviation. So I know that Z, okay, so basically I'm working now with this point over here. Okay, just this bit over here. We're linking up all of those things. How are those things all linked up? Well, we know that Z is equal to x minus mu over sigma, right? Okay, and I'm working with a Z score of negative 1,28. And a Z score of negative 1,28 goes with an X score of 5,2. Okay. But mu is equal to it's 2 lots of sigma. So it's going to be minus 2 sigma over sigma. Okay. So we get negative 1,28 is 5,2 minus 2 sigma over sigma. Okay, go work out sigma then. Well, I do my therapy. Okay, so I get negative 1,28 sigma plus 2 sigma is equal to 5,2. Okay. And Nsumi and Saka, what did you get for sigma?
So, sir, I am still busy, but so far you
Okay.
say 2 sigma.
I'll give you 30 seconds. I'll give you 30 seconds.
Okay,
Go,
thank
go,
you.
go.
So my number is suspicious, even though I'm doing the same thing.
Did you get 7 comma something?
No, sir.
So I get negative 1. Okay, did you go negative 1,28 sigma plus 2 sigma?
So I realized that when I added, I made a problem when, I made a mistake when
That's
adding
great. That's fine. Okay,
yeah.
right, well, you're out. So sigma is 7,22. Okay, check that later. And so mu is 2 times sigma. So mu is equal to 14,44. Thanks for trying though, Nsako. Nsako, what? Nsako.
Sorry.
Right, okay.
So that's
All
my
right.
second name.
I know, but I like it. Right, guys, it is 5. I need a break. Okay, we'll start at 5:25. Okay, go walk around. Okay, stick your head under a tap. Have a vodka. We'll see you at 5:25.
Supposed to leave.
But Lali, what? Are you talking to me or somebody else?
Sir, it was me. I
Who
was
is,
asking
who is me?
Leia.
Yes, Leia.
Sir, I'm so sorry, but you are being completely frauded right now. It is BK. Sir,
BK, I'm going to hunt you down.
she's too scared to ask her own question, sir.
What does she want to
No.
ask, Leia?
I was just asking if we were supposed to leave or stay on the call and just leave
No,
outside.
stay on the call. Stay on the call. Just go for a walk for 5 minutes.
Okay, see you soon.
Thank you, Leia. Holy shit. All right, let's see if we've got anyone here. Okay, see who we got. Well, we have Bukanya, who went on a break but stayed on the call. Gia, Umika, Leia, Zara, Unsumi, Butlali, Olivia. Okay, so I'm going to pick on a bit now. Picked on Butlali a little bit, but I'll pick on her some more. Olivia, ooh, Leia and Zahra. Haven't picked on them. Okay.
So Zahra asked if you would pick on her, please.
Is she awake?
Leia, I will end you.
Do you have coffee, Zahra, in front of you?
So I have a Red Bull in front of me.
Okay, good. Just don't mix it with Bar Plus. Okay.
Oh, yes.
No Bar Plus and Red Bull, guys. Okay. Right. Let's do this. Okay, I really like this paper, actually. I know you're thinking, oh, that is just weird. Right, let us go. We've done question 2, eh? No, I haven't finished. Okay, we're on question 2.2. Right, try start 2.2. We might go a bit beyond 6. I want to get up to the end of question 4. If you want to leave, you can leave. I will not hold it against you. Okay. Right. So 2.2. It says a 6-sided die is suspected of bias. Which unfair dice. Okay. Right. And then what I love is in this explanation, the dice is thrown 100 times and it is found that it lands on 620 times. Note that a dice is a cube, with each side having a different number of dots in it, ranging from 1 to 6. In case you've been living in a cave. Right, A. Calculate a 94% confidence interval for P, the probability of a dice landing on a 6 on any throw. So there are 2 types of confidence intervals. Okay, one for mu. Okay, so if you're doing a confidence interval for mean, okay, remember, so for means, in other words, averages, what do you do? How do confidence intervals work? Well, what happens is you do an experiment. For the experiment, you get X bar, okay, which is your average for your experiment. A confidence interval then says, okay, we go calculate an upper boundary for mu and a lower boundary for mu. Okay, what's the formula we use? Well, if you go to your formula sheet, okay, and you look 3rd row from the bottom, no, I'm not, 2nd row from the bottom, you've got a formula that says X bar, what? X bar, yeah, plus minus Z sigma over root N. That, guys, is your formula for confidence interval. What they don't write, okay, is that mu is equal to. So add, if you haven't done that, add mu is equal to the second formula for the bottom of your formula sheet. So the plus and minus, the plus bit gives you your upper boundary. Okay, if you go plus, okay, the negative bit, okay, gives you a lower boundary. And then we can say we're 96% confidence that the mean for the population, mu, remember, is mean for the population. X bar is mean for your sample. So that's the one situation where you use confidence interval. The other is for proportions. Okay. And in proportions, if you look at the formula to the right of that, you've got a formula on your formula sheet which says P plus minus Z, okay, P1, what? P1 minus P over N. Okay, that's your formula for confidence intervals for proportion, but you need to change it a bit. I want you to write P is equal to, and then in the formula, every time you see a P, put hat, P hat. So X bar in this formula is based on your sample mean. Okay, the Z score comes from whatever your confidence interval is. Sigma is standard deviation, and N is the number in the sample. Okay, here P is our estimates for the population proportion. So what you do now is there's a study done. The study gives you a sample proportion. And based on that sample proportion, plus the number of things in the survey, you get an upper and a lower boundary for the population proportion. So what happens on your diagram is P hat, the sample proportion, just like X bar lives here. And you're going to get a lower boundary for P and an upper boundary for P based on this formula. Okay, and then I can say I'm 98% confident that the proportion lies between such and such. Okay, so in this case, we're working with proportions. So first of all, the study of this dice. Okay. So you've got a dice, which is a singular of die. Okay, so first of all, go, based on the study, go tell me what p hat is. Roger, what's p hat? Well, p hat is equal to, the dice is thrown 100 times, and it's found that it lands on a 6 20 times. So Leia, what's p hat going to be? Oh, Leia, don't pretend you're not there.
So you see, I did it.
Yes.
I did it with like the mu lower, like the mean mu lower and the mu upper.
Not out of 6. Right. So,
So
yes, not come. Okay. This is what happens when you bully Zahra. Karma comes. So p hat, it's nothing to do with means. Okay, it's a proportion. The word mean isn't anywhere. Okay, so p hat is the number, if x is equal to the number of, p is equal to probability of getting a 6. The proportion of 6s, in other words. That's what we're working with. Okay, what proportion of 6s? What's the probability of a 6? Okay, so from the experiment, okay, how many times? So if x is equal to proportion of 6s, p hat is equal to 20. You got 26s out of 100, which is 0.2. Okay, Zahra and Leia, you're going to work on this question together. Zahra, no doubt you did the right thing.
So I'm sure she did the wrong thing.
Okay, so p hat is equal to 0.2. Guys, it's proportion. That's the sample proportion, right? So what we've got now is we've got, okay, a normal distribution of proportions. Okay, and on this axis, we've got proportions, and there's Z scores, right? P hat lives in the middle, so your sample proportion was equal to 0.2. So come on. Okay, 0.2 lives here, right? So based on that sample proportion, we have to go get a 94% confidence interval. So 94% confidence intervals are always 2 sides. Okay, and my objective is I want to find the upper boundary for P, which is the proportion of 6s for the entire thing, and the lower boundary for P. That's what I've got to try and work out. Okay. So first of all, though, I need my Z scores that go with that. I need to find out what the Z scores are there and there. To do that, I use my confidence interval. My confidence interval is 94%. Okay, but on a table, we just look up this area over here in blue, and that's going to be 94% divided by 2, which is 47%, I think, which is 0.47. So you're going to look up an area of 0.47, okay, and you're going to get this Z score over there. So go look up an area of 0.47. So we know H of Z is 0.47. So what did you get, Tweedledee and Tweedledum, for your Z score?
1,88.
Well done. And thank you for the R, Zahra. Right, okay, so that's 1.88, and that's negative 1.88 over there. Right, so your Z score always comes from your confidence interval. Okay, right. So now we go use that formula, and we go find the upper and the lower boundary for the proportion of 6s for the entire population. So we're going to go P is equal to P hat, which is 0.2, plus minus Z score, which for that confidence interval is 1.88, P hat, which is 0.2, 1 minus P hat, which is 0.8, over N, and they threw the dice 100 times. So you're going to end up with, I use interval notation, P is an element of two numbers, and that's going to be your lower boundary and your upper boundary. Your lower boundary must be below 0.2, your upper boundary must be above 0.2. This, guys, if they ever talk about a confidence interval width, this is your width of your confidence interval. Okay, between upper boundary and lower boundary. Okay, so I get P as an element of negative 1,88. No, I meant rubbish, Roger. Okay, Tweedledee and Tweedledum, what is your lower boundary?
0,1248.
Thank you, Tweedledee. And the other one?
0,2752.
Well done. Okay. So what have we worked out? We've worked out that for this particular dice, if you threw it a gazillion times, in other words, for the infinite number of times, that we would then be 94% confident. Okay. So this is for like the entire population. In this case, the entire population is not throwing the dice 100 times, it's throwing the dice a gazillion times, or however many times you throw it. So it would be 94% confident, that you'd end up with the probability of getting a 6 being between 0,1248 and 0,2752. Okay? So we're working with the population in this type, it's a bit of a weird question, is if you throw the dice lots and lots of times. That's what they mean by the population. Okay, based on the sample, we're 94% confidence that this particular dice would give you a probability of a 6 being between 12,48% and 27,52%. Be very careful. Ask yourself, am I working with means with confidence interval, or am I working with population proportions? Right. So B says, use your answer in A to comment on whether the dice may be biased. So,
sorry, sir, I have a question.
Yeah.
I was wondering, would you lose marks if you use square brackets instead of curly brackets for the interval?
Normal distribution, it never makes any difference because the probability at that specific point is 0. So this, on a normal distribution, your brackets make no difference because the probability at that particular z-score is 0. So including it or not including it doesn't matter.
Okay, thank you, sir.
Does that make sense?
Yes.
Okay, because on a normal distribution, like if I said you're running a race, what's the probability? Remember, normal distribution got to be infinitely accurate. So really the question is, what's the probability that you could run a race in 9,42765,320? It's effectively 0. So an individual probability on a normal distribution is 0. So that's why it doesn't matter whether you include the endpoints or not. Okay, right. So for B, if the dice was yeah.
Just one question. So how do you determine when you use p hat like that stuff or the mean?
Because there's nothing about a mean in this question. They don't say an average, they don't say the mean. They would say to you the mean of the sample. So they'd give you a whole lot of data, whatever, and they could say calculate the mean of the sample. Or they would say to you, Johnny does an experiment. He finds that the mean number of loaves of bread baked in a day is 750. Bah, it's mean. You with me? But if it's something out of something, you're working with proportion. So you tell it it's mean because they'll tell you the mean. That's basically it. Anything where they say to you, in a survey, they found that 50 out of 1,000 people in South Africa, had a car. That's not the mean. That's a proportion of people with a car. So P hat would be 50 out of 1,000. But if they said to you, the average, a survey reveals that the mean number of people, you see, you couldn't answer that question like that. It's proportion. But if they said to you, a survey reveals that the mean cost of a car in South Africa is 500,000 Rand, then you're working with the mean formula. Does that make sense, Leah?
Yes, thank you, sir.
You've got to say yes, otherwise I'll just go on and on and on. Right, so it says, use your answer in A to comment on whether the dice may be biased. So what have we just worked out? We've said that, if you throw the dice a lot of times, we'd expect the number of sixes, the probability of getting a 6 to be between 12,48% and 27,52. For an unbiased dice, what's the probability of getting a 6? Good. It's 1 out of 6, right? And 1 out of 6 is what? About 0,1666 recurring, right? so about that, right? So if the dice was unbiased, the probability of getting a 6 would be 16.67% or 0.1667. Okay. Well, for this particular dice, okay, the probability of getting a 6 was between 12.48 and 27.52. Does this value fall in that interval? It does. Okay. It falls, okay, in the interval over here. It's between these two values. These two values are what you'd get, okay, for our dice. Okay, an unbiased dice would fall within those values. So our dice is fine. There's no bias. If it fell outside of those values, okay, then, so if these values was like, I don't know, say this was 0.5, 0.2 and 0.3, then you could say there's a bias going on. Okay, because an unbiased die doesn't fall within the interval of our die. Yeah, I'm not going to get bogged down by that. Right. Moving on. Question 3 is pretty neat. Okay, so this is just a probability distribution. Okay. It's a probability mass function because it's working, okay, with remember, probability density functions are for continuous data. Probability mass functions, okay, are for and they don't even have dimension. You can just see that this is a probability mass function because the data is discrete. Okay, if you haven't watched the PDF, I don't know what the other class have done in this section, but I did send a video about, okay, not the one I did live, the ones I sent on that PDF, I'll resend it. Okay, you need to watch that, please. But remember, no mode or median for tomorrow's test for PDFs. So discrete, so it's a probability mass function, right? Okay, the first question says, give the expected value of, given that the expected value of X is 0.67, find the values of P and Q. Right, so first of all, who should we have? Olivia and Butlale, you're going to be joining me for this question. Are you still there, both of you?
Sir, I have no idea what a probability mass function is.
Okay, but you asked Butlale. Okay, right, let's have Rose. No, we haven't heard Rosemary. Who else is here from my class? Anyone? Any volunteers to join
So
Rose?
BK.
Yeah,
Okay.
BK's in your class, sir.
Okay, right.
Yeah.
Leia and Zara, because you're volunteering, other people come back. Right, you guys are doing the sum with me again. Okay, don't volunteer other people. Okay.
Yes, sir. Thank you.
Okay, so in this question, okay, if something's a probability function, what's a probability function? You put in X values and you get out probability values, right? So this is a probability function. You're putting in X values of 0, 1, 2, and 3, and it's spitting out the probability. So this is saying the probability of getting a 0 is 0.5, of 1 is 0.35, whatever it might be. Okay. So first of all, if it's a probability function, what are the probabilities, Tweedledee and Tweedledum, what do those have to add up to?
1.
Oh, ticket yolks, 1. Okay, so you're going to go, this blue is bad. Okay, so we're going to go, all of these things have to add up to 1. So your first equation is that 0.5 plus 0.35 plus P plus Q must be equal to 1. Okay, we're going to ultimately solve these simultaneously, so let's isolate one of the letters. Okay, so go get P on its own, could have been Q. So P is going to be 1 minus 0.85, which I think is going to be 0.15, eh? Am I right?
Yes.
Minus. Okay, so there's your first equation with P and Q. Okay. Now they tell us that the expected value is 0.67. Now, if you go to your formula sheet, okay, let's go have a look at your formula sheet. And now there are a couple of things about expected values. So that formula that you got in the middle, which says E of X is equal to NP, that's for a binomial distribution, right? Which can also be used for the normal approximation to the binomial. On the bottom right of your formula sheet, you've got a formula which says the expected value, also known as the expected mean, is equal to sigma X times the probability of X being equal to X. Okay, that's a mathematical way of saying the expected value, so in this case, sigma means go add up, right? So E of X is going to be, you're going to take each X score, okay, and multiply by its probability. So for this one over here, it's going to be 0 times 0,5, which is obviously just 0, so you could leave that out. Plus, sigma means add, okay? Then you're going to have 1 times 0,35, okay? Plus 2 times P, okay? Plus 3 times Q. Okay, and they told us that E of X was 0,67. So you're going to get 0,67. Right, let's go add up the numbers. So you're going to get, somebody do this for me. I can't find my calculator. Okay, Zahra, go 0 times 0,5. That's just 0, so that's gone. Okay, so I'm going to get 0,35. Okay, you don't have to do anything. So 0,67 is 0,35, that's that, plus 2P plus 3Q. Okay, if you want to simplify it a bit, you can. 67 minus 35 is 32. So 0,32 is equal to 2P plus 3Q. Right, so now I've got a second equation with P and Q in it. Okay, so now go combine those two things and solve them simultaneously. So if you sub 1 into 2, you get that. So solve for Q. Okay, don't worry about the maths really at this point. And you should get Q is equal to 0,02. Okay, and if you sub back in, whoa, and solve for P, according to the memo, you should get P is equal to 0,13. Any problems with that? So, expected value, okay. The expected value, guys, is always between the two highest probabilities. So our expected value is 0,67, which makes sense because 0 was 0,5, that was the biggest probability. 1 was 0,35. So it's in the middle of those two, right? That's the most likely, okay, outcome, even though it actually doesn't exist. It's theoretical because this is discrete data. So the probability actually of getting 0,67 is 0. All right. Okay, now the next question says, using the probabilities above, okay, so we're going to need those two values for P and Q. Okay, go find the standard deviation, right? Now, again, if you go to your formula sheet, okay, and you look on the very bottom formula, okay, which is your formula for the variance of X. So it says this, variance of X. So this is for any discrete distribution. Okay, the variance of X, but not for a binomial. If we're, basically, where you're given the table, okay, I use this, is going to be E of X squared, it says, minus, so this is when you're given a table and you want to find the variant probability distribution table, okay, and you want to find the standard deviation or the variance. Okay, so that's your formula for the variance. Once I've got the variance to find the standard deviation, I square root that. That's the relationship between variance and standard deviation. So E of x, we were told E of x, right? Okay, they said E of x was equal to, in the question was 0.67, right? The expected value. So this last bit here is going to be minus, open brackets, E of x, they told us was 0.67 squared. E of x squared is not the same thing. What this means is you square the individual x values. And sum them up. So in other words, to work out E of x squared, okay, well, E of x, we just went 0 times 0.5 plus 1 times 0.35 plus 2 times b times, okay. Now we're going to say E of x squared, you square the x value. So it's going to be, this green one is going to be 0 squared times 0.5. You can just ignore that because that will just be 0, so you didn't have to write it down. Okay, this red one, E of x squared, will be plus 1 squared times 0.35. Okay. Now, we know that P was equal to 0.13. So to work out E of x squared is going to be plus 2 squared. Okay. That's 2 squared. You're squaring the x values. And P, the probability over here, is equal to 0.13. Okay. And then the last one, this one here in black, is going to be plus 3 squared, okay, times Q, and Q is equal to 0.02. That's what they mean in that formula by E of x squared. That's x squared in the bracket means square the individual x values and then times by the probability, as opposed to E of x. When you're working out E of x, you just say x times probability. Okay. So if you work out E of x squared, we're not going to waste time now doing that on the calculator. You should get E of x squared, okay, being equal to, I don't know, okay. But the whole thing, did somebody done it?
Yes, it's 1,05. Someone can correct me if I'm wrong.
Okay, let's have a look. So thank you, Butlali, 1,05, right? So I've got E of x squared is 1,05. And this one over here, E of x all squared is 0.67 all squared. So in other words, your variance of x is going to be E of x squared, which is 1,05 minus 0.67 squared. Okay. So then your standard deviation, okay, will be equal to, so your standard deviation of x will be equal to, what's the relationship between standard deviation and variance? Standard deviation is the square root of variance. So your standard deviation will be 1,05 minus the square root of that whole thing. Somebody stick that in the calculator for me.
So I got, can I say?
Yeah.
I got 0,775.
Good, Lolly, high five yourself.
Yay!
Okay, 0.7753. Okay, right. Okay, I'm going to have another 5-minute break. Teaching stats is exhausting. Okay, and then I'm going to come back and do, okay, make it a bit longer. If you need to go, you need to go. We'll go, okay, we'll start at 3 minutes past 6. Okay, and then I'm going to do 3.3 and question 4, and then we're going to call it a day. If you need to leave, you can leave. Okay, I am recording it. So if I talk to myself, that's fine. All right, see you at 3 minutes past 6. Just teaching for another 25 minutes. So we're going to teach till 6:30, okay? Got some coke and
The other one they in the freezer. It's not all going now. You will see.
I'm going to leave now.
It's not. What's the next one?
Okay, guys, I'm not going to do the next question I'll run through later on, but I'm going to do something that's more relevant for your test tomorrow. Okay. I can't erase that. Is anyone okay? Anyway, hopefully you're back there. Okay. So I'm going to do this question here in terms of probability density functions. Let's just pick one. So I'm going to do, I'm sorry to my class, I know you're repeating this, but maybe you didn't understand it the first time around. So we're going to do this question 5. Okay, so just a reminder what a probability density function is. So a probability mass function, okay, remember a probability mass function, hang on, let's just go, actually, I think we've got that. If you look, there's a nice summary in your textbook, okay? It's really worth knowing this page. Okay, so in a probability mass function, okay, right. Can you guys hear me?
Yes, sir. What
okay,
page is this?
This comes from the textbook. So it's on page, it's on your textbook, I think, round about page 291 of your textbook. Okay.
Thank you, sir.
Okay, so on page 291 of your textbook. So it says here the difference between the two. Okay, probability mass function is for discrete. Okay, probability density function, both of them are probability functions because you put in x values and you get out probabilities. Yeah. So in discrete data, you'd represent a probability function like something like bars or whatever. Okay, here you have x, here you have probability x is equal to x. You literally would read off your probability. So if that was 0.2, that was 0.4, whatever, that's 0.3, that would have to be 0.1 so that they add up. Your probabilities are your y values for your individual x values, 0, 1, 2, 3. Okay. In a probability density function, a normal distribution is a type of probability density function. Okay, it's a complicated one, the formula for that function. But basically, if you got x, in a probability density function, you're working with continuous data. Okay. And just like in a normal curve, the y value isn't the probability. Okay. So you've got f of x on that. On this probability mass function, your probability is your y value. Here, f of x is a curve, but the probability, it could just be a straight line, okay, is the area under the curve, just like in a normal distribution. So your area is your probability, and so here the y-scores have to add up to 1. Here your area has to add up to 1. Okay, so the area is your probability, so that must add up to 1. Okay, so in a probability mass function, which is kind of the example we did just now, the sum of your probabilities has to be equal to 1. In a probability, the area under your curve is equal to 1. Now, what gives us the area under the curve? Well, if I've got a curve like this, okay, and the function is defined between a and b, and this is curve f, okay, then the area under the curve is your probability. The curve has to be above the x-axis, otherwise even though the f values, the y values aren't your probabilities, the curve must be above the x-axis because otherwise the probabilities are considered to be negative. Okay, so here, this continuous area must be equal to 1. So to find the area under the curve, the area that I've shaded in would be equal to something called the integral between a and b, between the bottom interval and the top interval of the function with respect to x. Okay? We read this as the integral between a and b of f of x with respect to x. So if this is a probability function, that answer would have to be equal to 1. Because if it's a probability that just like in a normal distribution, the total area under the curve in a normal distribution is 1, right? Okay. So for any probability continuous distribution, in other words, for any probability density function, the area must be equal to 1. And what gives you the area of a continuous function is the integral between a and b. Okay. I can't get into the calculus of that now, but there's a button on your calculator which we're going to use. Okay. So for a probability density function, the area under the curve must be equal to 1. Okay, don't worry about the next. Okay, what you do have to know though, we've just done this one over here in the previous example to find the mean. Okay, the mode is that has the highest probability. That's pretty obvious. Okay. So, but what you got to know for tomorrow is this formula over here. The expected value, okay, in other words, the mean of a probability density function is the integral of x times f of x over the whole area. I'm going to do some examples like that now. Okay, so that table is pretty useful. For tomorrow, you don't have to know about the median and the mode, but you do in 2 weeks' time. Okay, so if I look at this question, let's do this question 5 over here. It says a random variable has a probability density function given by the formula over there. Okay, so they're telling you it's a probability density function. Okay, I don't know what that curve is going to look like. Okay, but if we did draw the curve, if you're asked to sketch a function, then you just, okay, first of all, sorry, hang on, first question. Show that k is equal to 4 over 27. Well, what's going on? Okay, if you had some curve, I'm not sure of the shape of it, okay, but whatever it might be, you've got some probability density function, okay, which exists between 0 and 3. The shape could be anything, right? And they're telling you this is a probability function, which means that this area under the curve, okay, because the area under the curve for a continuous function, okay, is the probability. That area has to be equal to 1. And this function is defined between 0 and 3. So you're going to need your calculator, okay? So in order to find k, because they tell us that it is a probability density function, we say the area under the curve, the integral between 0 and 3 of my function, this dx just means that the variable we're working with is x. Okay, so the integral between 0 and 3 of f of x, what does that represent? That represents the area under that curve. We know that that must be equal to 1. Okay, so in other words, the integral between 0 and 3. Well, what is f of x in this particular case? It's k 3x squared, 3x squared minus x cubed, okay, with respect to x, okay. So we know that that must be equal to 1. Now, if you got the integral of k f of x with respect to x, if that's a constant number, in other words, as long as it's not x, you're going to always remove that. Okay, so here we're going to write this as, okay, the integral k times the integral between 0 and 3, okay, of 3x squared minus x cubed, okay, with respect to x, that must be equal to 1. So this area over here, this thing over here, we're going to just simply work out. The textbook does it manually. You don't have to do it manually. You're going to work it on your calculator. So if you get your calculator, okay, the integral button is kind of second from, it's on the top row, second from the left. Okay. Right, it looks like this integral, square there, another square there. Okay. Right, so you're going to press that button. So you're going to get k times, and we're going to work out that number. This thing, whole thing works out to be a number. So you're going to go the integral. Okay, the function, to put in an x, you're going to use alpha x. Okay, the x is above the right-hand bracket. So you're going to go 3 alpha x squared. Okay, so it should look exactly like that, like it's written down. It should look like that on your screen. Minus alpha x cubed. Okay, close that bracket. Between the bottom number, scroll down, 0, scroll up, and 3, and press equals. Okay, and you should have got 27 over 4. So you get k times 27 over 4 is equal to 1. So k is equal to 1 divided by 27 over 4, which is 4 over 27. So I've done part 1. I've shown that k is equal to 4 over 27. Okay.
Sir,
Mm-hmm.
I got 18. Wait. For the like filling in of like the 0 and the 3, is the 0 at the bottom and the 3 at the top, or is?
Yes, 0 has to be at the bottom. That 0 is the most left boundary. So the 0 has to be at the bottom, the 3 has to be at the top.
Okay. So I'm not entirely sure what I did wrong. But
Try again.
Okay.
Okay, but it is that. Did anyone else not get, did anyone get 27 over 4? Just shout, me. No, no one's left. Okay.
So I got 27 over 4.
Is that
I got it. I got it.
Yes.
You guys are good people for still being here. Right. And getting the right answers. But Lolly, you were wrong. Right. Okay. Okay, sorry about that. Right. Now, if you look at that summary, okay, I'm going to change B to find the mean. Okay. So if I said to you find them, so I'm going to change B to find the mean of the PDF. Or of f of x in this case. Okay. So if you go back to that table that I in the textbook, it says to find the mean. Well, just like you've got that formula that says the expected value is equal to x times f of x times, you've got this formula over here, which says e of x on your formula sheet is equal to the sum of x times the that's for discrete data, probability of x is equal to x. Okay. For continuous data, okay, for a probability density function, in other words, okay, your mean, okay, is going to be equal to, integral means the infinite sum, so that goes with that, of x times f of x with respect to x. So that's a formula to find the mean of a probability function. You've got to know that, okay, it relates to this for discrete data. This, the integral sign actually means an infinite sum. Okay. Right. So now, if we go work out the mean, we're going to use our calculator again. And the mean is going to be the integral between where and where? Between 0 and 3. Okay. I know now that k is equal to 4 over 27. Even if you couldn't work it out, use it. Okay. So between 0 and 3 of 4 over 27. Okay, I've replaced k with 4 over 27. Then it's going to be 3x squared minus x cubed with respect to x. So that's going to give us the mean of this probability function. Okay. So go stick that into your calculator exactly like it is. If you want, you could put the 4 over 27 to the front, but you don't have to. So go practice your calculator work. So it's it's 3 alpha x 3 alpha x squared minus x cubed alpha x cubed. Okay. Right, close that bracket between 0 and 3. Guys, what have I done wrong? There should be an x here. X times that. X times f of x. Sorry. So it should be the integral of x times f of x, which is 4 over 27, okay, times 3x squared minus x cubed. I forgot the x. Because that's for the mean. For the mean, you've got to add that extra times of x in. So I'm going to actually take out the 4 over 27. Apologies. And I'm going to be left with the integral of 3x cubed minus x to the 4 with respect to x. Okay.
So how did you get that?
Because the formula for the mean is the integral of x times f of x with respect to x. So here is my x value, right? So I've got to put that x. F of x is the original function they gave us this over here, right? So f of x was equal to, here, in this question, you with me? F of x is this formula over here, right? But now you know that k is equal to 4 over 27. So f of x is that thing over there, right? Are you with me, Batlali?
Oh, yes, sir, right.
You've got to know that formula for mean, right? So we have the extra x. I can remove the constant, so I removed it. You don't have to. So now you're going to find the integral between 0 and this function is defined between 0 and 3. So on your calculator, you're going to enter this, Batlali, the integral between 0 and 3. So that's what you're going to enter on your calculator. You with me?
Yes.
Because I just distributed that x into the bracket.
Oh, okay, yes.
That's all I did, okay? And I removed the 4 over 27 because it's a constant. You don't have to remove the 4 over 27, you could leave it there.
Okay.
Okay, so you're going to end up with 4 over 27. Okay, so Batlali, let's practice this. Let's go put that into your calculator over there. So you're going to press the integral button, right? Between 0 and 3. Okay, and now I want... Okay, so I want the integral, okay, of 3x cubed. Okay. Minus x to the 4. Okay, between 0 and 3. And I get, little man in my calculator is working quite hard, 243 over 20. So if you times those, is anyone still there apart from Batlali? Okay, and if I go times that by 4 over 27, I get 9 over 5. In other words, 1,8. Did you get that, Batlali?
Yes, sir.
Okay. I don't know if it's just Batlali. Batlali, how many of the people, any other people left on the call, Batlali?
Yeah, there's like 6 people, 7 people.
The hardcore people. Okay, Batlali, tell me who I'm going to pick on next.
I think you should talk to Mika.
Mika.
Yeah,
So, no, that's not fair.
It's Mika Okay.
Yeah.
Okay, you pick somebody.
Let's go in Sumi.
Okay, right.
Ah,
And Sumi and you're going to do this with me, both of you. Okay. All right.
yes.
So I'm going to add one last question, and then we understand probability density functions for tomorrow. Right. There's other stuff you need to know for your exam, though. Okay, I'm going to make a question C. Okay. So I want to figure out, determine, here's the question. Okay, the probability. Oh, I'll be back now. Okay. I want to drown my tree, guys. Right, determine the probability that, let's say, probability. How was the question? Find the probability that x lies between 1 and 2. Okay, for this, I'm still working with this function over here. Okay, so what we're going to do, guys, is so I've got this function. I don't know exactly what it looks like, but it goes from 0 to 3. Okay, whatever it might look like. Okay, and they want to find the probability. What's probability in continuous functions like a normal distribution? It's the area under the curve, right? So I'm looking for that area over there. That'll answer that question. Okay. What gives us the area is the integral of the function. So to find this area, it's going to be equal to the integral between 1 and 2. Okay. There's the 1, there's the 2, right? Of the function f of x with respect to x. But f of x, okay, is going to be equal to, well, here's f of x over here. Here's our function. So it's going to be equal to the integral between 1 and 2 of 4 over 27 times f of x, which is not x times f of x, just f of x. So anytime I use x times f of x is to find the mean of 3x squared minus x cubed with respect to x, right? Okay, so we're going to work that on my calculator. For some reason, I always prefer taking out the constant. So I'm going to go 4 over 27 times the probability between 1 and 2 of 3x squared minus x cubed with respect to x. Right, so go and work this out on your calculator. Okay. So I'm going to go integral between of 3x squared minus x cubed minus x cubed. Okay, between 1 and 2 now. So the lower boundary is 1, the upper boundary is 2. Press equals. And hopefully you got 13 over 4. So you get 4 over 27 times 13 over 4, which gives you 13 over 27, which is good because it's less than 1, because it's a probability. Okay, guys. Any questions about that? So the things you need to know about probability density functions in terms of tomorrow. You need to know how to find that k. You need to basically know how to find the mean and a probability. That's it. I don't want you to stress about median and modes and all of that stuff now. Okay, guys, I'm going to call it a day. I'm knackered.
Oh, sorry, before you leave, I just have a question.
Yeah, sure.
You see how with the examples we've done, they've given us f of x. Will there ever be an instance, like in terms of tomorrow, where we must find f of x and we're given information? Yeah, banna.
Yo, say left.
You.
You really said bye.
Can you hear me? Hello?
Yes.
Sorry, I don't know what happened there. Yeah, carry on.
So I was asking, in the examples we were like given f of x. So I wanted to ask if tomorrow we will have to find f of x.
No. If you can do, in terms of probability density functions, okay, if you can do what I've done now, you're fine. Okay.
Okay, thanks. Sir.
Okay. There are questions where they could ask you to find, they could give you a graph, like a simple straight line graph. So I think, let's just do this one quickly. If I go, no, I don't want to, oh, hang on. So if I want to go to the exam, and there's a question here. Okay, so it says, I'm just going to do that last question. Okay, this is what you're asking. So in figure T, don't worry about the other questions for now. So figure T, okay, is this one over here. T, this graph here. So the question says, use figure 1 to find the probability that T is less than 0.5. So there, and swimming, you
we
with me
can't
still?
see your screen.
Wait. Okay, sorry. Control H, share screen. Thank you. Share screen. Okay. All right. Can you see that now?
Yes, sir.
Okay. So this question over here, which is from the exam we were doing, right? Okay. It says use figure 1 to find the probability that t is less than 0.5. So I'm looking at this figure over here on the top left. Are you with me? You got that question? It's on page 4 of the 2020 paper.
Yes, sir.
Okay. So here, and so you're not given the function, right? But we can find that function pretty easily, right? How can I find that function? Well, it's a straight line graph, right? So if I go use, so this is for question C, y is equal to mx plus c. Okay. Well, c is a y-intercept, right? So c is equal to 1. Okay. And then I can either go, so I've got y is equal to mx plus 1. To find m, I can either get to say that the gradient is change of y over change of x. Okay, which would be negative 1 over 2. You with me? You've gone 1 down, so it's negative 1 and 2 to the right. So you could just do it by inspection and say m is equal to negative a half. Or I could substitute in that point 2, 0, and you'd get 0 is equal to 2m plus 1, which gives you negative 1 is 2m. So negative a half is equal to m. Either way, okay, you end up with a function of f of x is equal to negative a half x plus 1, right?
Yes, sir.
Okay, so that's your probability density function in this case. So now to answer this question, it says use a figure to find the probability that t is less than 0.5. Okay, so the probability t is less than 0.5. Okay, so 0.5, basically we're looking for this area over here. If that's 0.5, right? How do I find that? It's the integral between 0 and 1. No, between 0 and 0.5, sorry. You with me? Because the bottom number is 0, the top number 0 of the boundary is 0 and 0.5. So, does that make sense?
Yes, sir.
Of the function, which is negative a half x plus 1, right? So that's going to give me this area over here. And then
Okay, sir.
and then if we put that into your calculator, you're going to get the integral of negative a half or negative 0.5 x plus 1, close that bracket, between 0 and 0.5. And you should get an answer of 7 over 16.
Okay, thank you so much, sir.
All right, guys. All right, guys. Thank you, everyone.
Thank you, sir.
Thanks, sir. Bye.
Okay,
you,
guys.
Thank you,
As I
sir.
say, please don't
Thank you,
stress.
sir.
Please don't stress about your mark for tomorrow. Like I say, I'm not worried at all about the mark tomorrow. Okay, it's just about starting to get your head into this whole section. Stats is not easy. Okay, so also don't feel dumb if you're struggling a bit at this point. Okay, guys. Okay, so just
Okay, thanks, sir. Bye,
persevere
So, sir,
and
if we fail,
we'll-
it's
we'll-
okay.
it's fine. Perfectly, it really is. Okay, so you don't even have to, as I say, we'll play with those marks. I'll make it fine. But try your best. But and then I'll do quite a few more of these sessions, okay, before the exam, okay? And try go to that course
Thank
on
you,
Sunday
sir.
if you can, the one I think said for that at St. John's. All right, guys, have a good one.
Okay,
Bye,
thank you,
sir.
sir.
Thank you, sir.
Bye, guys.